Look at the first objective on this test, which is solving quadratic systems. In each of these, you're always told what y is for the quadratic expression. So all you're doing is you're taking this expression for the quadratic and replacing it where you see the y. So I've got negative 2x plus, and then 5x squared minus 7x plus 5 equal to 7. So the only thing that's changed is that y is now that expression. From here, I can combine my like terms because I see that I've got a negative 2x and negative 7x. So those will combine, oops, wrong one. Those will combine to make negative 9x. So I'll have 5x squared minus 9x plus 5 equal to 7. Whenever you have a quadratic, meaning that little exponent of 2, it's a clue that you can solve by factoring your quadratic formula. In both cases, you need to subtract that 7. You need to get a 0 on one side. So I'm going to end up with 5x squared minus 9x minus 2 equal to 0. For this problem, I'm going to be using factoring to solve, but you can use the quadratic formula. So I'm going to show the quadratic formula in the second problem. So for this, when I'm doing box and diamond, when I'm solving by factoring, I place the 5x squared in the top left and negative 2 in the bottom right. I'm trying to figure out what these other two expressions will be. And so the way I do that is multiplying the 5 times negative 2 to make the top of my diamond. Negative 9 goes on the bottom, so that middle value on the bottom. I'm looking for two numbers to multiply to make negative 10 and add to make negative 9. So that'll be negative 10 and positive 1. So I place the negative 10x and positive 1x into the box. And now I can see that the 5x squared has to be split up with 5x and x, because then 5x times negative 2 will make the negative 10x. X times 1 will make the 5x, or make the 1x. So now I can place the x minus 2, which is one of the factors, and 5x plus 1, which is the other factor, and that still is equal to 0. I can apply the zero product property, which is x minus 2 equal to 0, 5x plus 1 equal to 0. Adding a 2 means that x is 2. Subtracting 1 leaves me with 5x is equal to negative 1. Dividing by 5 gives me a decimal of negative 0.2. Now, we found x values, but we also have a y value, so we need to figure out that y value as well. So this is where we can substitute this into our equation at the top with 5x squared minus 7 times x plus 5. And once we do that, we get a y value of 11 for this one. Same idea with the second one. We're going to have 5 times negative 0.2 squared minus 7 times negative 0.2 plus 5, and that gets you the 6.6. So for each x value, in this case of 2, we get a y value, 11. For the other one, we get an x value of negative 0.2 and a y value of 6.6. You're going to have a lot more space on the test to find your two solutions, but these are the two answers that we're looking for. So I'm going to show this one with the quadratic formula. Same idea. We know what y is. Y is that big expression, so we're replacing the y with that big expression into the equation. So we've got 3x plus 2x squared minus 2x minus 11. We can equal to 4. So the only thing that's changed is this expression has now become that. So we can combine together these two x's, and we're going to get 2x squared plus x minus 11 is equal to 4. Getting a 0 on the other side, we're going to subtract the 4, and that leaves us with 2x squared plus x minus 15 equal to 0. You can definitely do box diamond on this, but I'm going to use the quadratic formula. So with that, we're going to get the x is equal to negative b. So our b value is 1, so that's from here. Plus or minus the square root of b squared, so 1 squared, minus 4 times a, which is 2, times c, which is negative 15. You want to keep those negatives in there as well. So it goes a, b, c. We're not including those x's. And this is all over 2 times your a value. So 2 times 2. So you're going to be given the quadratic formula on the test if you choose to use that. You do not have to memorize it. Oops, that's a C. All over 2a. So for here, when I simplify, I just write this negative 1 as negative 1. And I type into my calculator 1 squared minus 4 times 2 times negative 15. I get 121. And then when I take, that becomes 4. When I take the square root of 121, I get 11, so plus or minus 11 all over 4. This gives me two possible answers. When I'm adding the negative 1 plus 11, I get 10 over 4, which gives me 2.25. When I subtract negative 1 minus 11, I get negative 12 over 4, which is negative 3. And these are my two x values. So x is 2.25 or negative 3. Now I need to figure out the y values. Once again, my y is equal to that quadratic expression, so 2x squared minus 2x minus 11. So y is equal to 2x squared minus 2x minus 11. When I do that, I should be getting, and it wasn't 2.25, sorry about that, it should be 2.5. I think I was basing it off the next problem because there's a 2.25 in the next one. 2.5, so let me just switch those up. Makes it a little bit more wide space, but that's okay. All right, and so our y value for 2.5 is negative 8.5. So that means that I've got one coordinate point at 2.5, negative 8.5. Then the other coordinate point is when we substitute in the negative 3. So y is equal to 2 times negative 3 squared, 2x squared, minus 2 times the x minus 11. And when we do that into our calculators, we get 13. So the other coordinate is going to be at negative 3 for the x, 13 for the y. Last one I'm going to solve by factoring. So I'm going to have 5x plus 4x squared minus 12x minus 18 is equal to negative 3. So again, I'm replacing this in for the y because that is what y is. I can combine the like terms and add the 3. I'm going to do two things that simultaneously. So combining these two together gets me 4x squared minus 7x minus 15 when I add that 3 back in. So that's now equal to 0. I said I'd do this by factoring, so box and diamond. I'm just going to jump right into the diamond. So that's going to be 4 times negative 15, which is negative 60, with the negative 7 on the bottom. So when I'm looking at 60, all possible ways of making that, that's 1 and 60, 2 and 30, 3 and 24 and 15. I'm looking for them to subtract to make 7, not yet. 5 and 12, there it is. So negative 12 and 5. So into the box, and I've got 4x squared, negative 12x, 5x. So this has to be an x and a 4x to make the 5 and negative 3, and that will get me the negative 15, which it should be at the very bottom. So now my two factors are x minus 3 and 4x plus 5. And so this means that x minus 3 equal to 0, 4x plus 5 equal to 0 gives me a positive 3 for x and a negative 5 over 4, or negative, what was 1.25? I think I was thinking of the other one. So we've got those two x values. Let's plug it back into the y. So y is 4x squared, so 4 times 3 squared minus 12 times 3 minus 18, and this one is substituting in negative 1.25. So this would be 4 times negative 1.25 squared minus 12 times negative 1.25 minus 18. When we simplify this first one down, we should be getting for 3, negative 18. Oh, that's interesting. And because it matches up with the y-intercept. And that's where Miss Hellier says, I feel like, oh, no, that just means that we're passing through the origin. Okay, the y, I'm awake. The y value for this one is at 3.25. So our two ordered pairs are when x is 3, y is negative 18. And when x is negative 1.25, y is 3.25. So these are the two final solutions for this last one.